Good morning, you guys. So let's go ahead and look at the problems that are going to be in your Delta Math assignment. And just that way you've got an idea of what you're going to be doing. All right. So it just says here that we're going to be identifying relative extrema. Okay. So that means we're looking at our maximums and our minimums. Okay, so it says how many points on the graph represent a relative maximum? Okay, so you can see we've got arrows representing it goes off to infinity. But if I look right here, okay, I've got this peak and then I do have a valley. So B would be a relative maximum. Okay, and then you can also see this alternate explanation is that it's a change from increasing to decreasing. Okay. All right, so now if I go back to here, sorry, it says the function f of x is graphed below. What is true about the graph on the interval from x equals e to x equals infinity? Okay, so if I start at e and I go to infinity, what is the graph doing? Well, it is going, okay, to decreasing. So it says what is true? So it is positive and increasing. It is positive and decreasing. It is negative and increasing. It is negative and decreasing. Okay. Now here's the great thing about Delta Math. So let's just say you're like, I'm not entirely sure, but I know that it's decreasing. So you know you're going to pick this one or this one. Okay. Just click on one. Okay. I'm not even going to click the correct answer or incorrect answer. I'm just going to click one. Okay. So it's one of these two. All right, so let's look here. Okay, it says it is negative and decreasing. Okay, and it's because it's going down. Okay, all right. It's not like we're over here at C where we're going up, we're increasing. Okay, you've got to kind of just use a little bit of common sense. Okay, and if you're not sure, just guess. Okay, just guess and keep reading the explanations and keep looking at the highlights until you get better at it. Okay, that's the nice thing about Delta Math right now. All right, in behavior graphically. Okay, all right, so let's look here. It says the graph of y equals f of x is graphed below. What is the in behavior of f of x? Okay, all right, so now we're looking right here. Okay, we're going off towards negative infinity and we're going off towards negative infinity. Okay, all right, so that means our y values. Okay, so don't even worry about all this. Just don't worry just a minute. Okay, y is going towards negative infinity. So that means it's either this answer or this answer. Okay. Now here we've got negative infinity, we got positive infinity. Okay. All right. So now that I know that both my y values acknowledge that we're going to negative infinity, let me show you what they're talking about. As x goes towards infinity, y goes to negative infinity. Okay. Now if I start right here, okay, my x values, if I were to trace, my x values would get bigger, but my y values would be going off to negative infinity. Okay, and as x goes to negative infinity, so here, my x values, they are going towards negative infinity, so they're getting smaller and smaller and smaller. My y values are doing the exact same thing. All right, submit my answer. Yes. Okay, and there it is. And it's the same explanation that I gave you. All right, let's do another one of these. Okay, all right. So my arrows this time, both of them are shooting off towards positive infinity. Okay. Now remember, f of x is also y. Okay. So I've got positive infinity here, positive infinity here. I'm going to hold that because that says y is going towards negative infinity, negative infinity. That's not correct. This says negative infinity and positive infinity. And this says positive infinity and negative infinity. No, both of my arrows are going off in the same direction of positive infinity. Okay, this is just telling me that as x goes that way, and this one's telling me as x goes this way. Okay, submit my answer. Yes, got a green check. Okay, one more. All right, good. I'm glad it switched over to this one. Okay, so now I have one of each. Okay, but now I got to decide, so which one? So if I've got one of each, I got one of each here. These two are the same, so I would not use the second one. These two are positive. Okay, and then the last one, I got one of each. Okay, so I have to make a decision. Is it the first one or is it the last one? Just based on the fact that I have one of each. Okay. All right, so now this one says as x goes towards negative infinity. So as x gets smaller, the graph goes towards positive infinity. Okay, that's good. Then it says here as x gets bigger, x goes towards positive infinity. So as I go this way, y, my function goes down towards negative infinity. That's my answer. Okay. The last one said, I did not pick this one because it says as x is getting smaller, that graph should be pointed down. That's what that's saying. The graph should be pointed down. It's not. It's pointing up. Okay. So submit my answer. There we go. Okay. All right. Determine features of a polynomial graph. All right. So this one's great. This one kind of takes everything that we've done, okay, in the video and kind of puts it all in one question. Now, there's only a couple things I got to do for you. Okay. It says the degree of f of x is, okay, so it's odd or even. Okay. Here's how it works. Okay, if your in behavior is pointing in the same direction, it's even. If one of the arrows had been pointing up and one of the arrows had been pointing down, you would have said odd. Okay, so there's that. So that's the degree. Said the leading coefficient is. Okay, now this one you may have to do some trial and error. Okay, but the trial and error is, okay, based on the parent function. And some of you may look at where I have no idea what the parent function is. Okay. All right. Well, usually even functions, okay, their endpoints are pointed up. Okay. That's what they usually are. Okay. And their parent functions would be pointed up. Okay. This is pointing down. So the leading coefficient is negative. It's been flipped over. Okay. All right. There are blank zeros, real zeros, x-intercepts. Where does this graph cross the x-axis? Okay, right here. 1, 2, 3, 4. There are 4 x-intercepts and blank relative maximum values. So how many peaks? Peak 1, peak 2, peak 3. Submit my answer. Green check. Okay, and then you can see it's all nicely labeled. Okay, all right, so A, C, E, and G, those are your zeros. Okay, and then your peaks, you have 3 of them. Okay, all right, and then you can say leading coefficient is negative, both arrows point down, degree is even, end arrows point the same direction. All right, let's try another one. Okay, that one's just like it. Let's get to a different one. There we go. Okay. All right. The polynomial function f of x is graphed below. Fill in the form. Okay. The degree. Okay. So since my arrows are pointing in different directions, odd. That's the degree. So that means the exponent is like x to the 3, x to the 5th, x to the 7th. That's what it's saying. Okay. The leading coefficient is, okay, well, hey, if you're not entirely sure, take a guess. So let's just say positive. Okay, if you're not sure, okay, I'm going to tell you in a moment how to tell, but let's just say you don't know. Okay, there are blank real zeros. So x-intercepts 1, 2, 3, 4, 5, 6. Okay, and relative maximum values. Okay, that's a peak 1, peak 2, peak 3. Okay. All right. So if you're confident in that you know it's odd, you know it's 6, and you know it's 3, submit your answer. Okay. All right, if you're not sure about the leading coefficient, is it positive or negative? Okay, submit, yes. Okay, I knew I was getting the red X, okay? All right, it says the leading coefficient is negative because the end behavior on the right is down and the left is up, okay? So you want to choose positive right here, okay? If this side, the left is pointing down and the right is pointing up, okay? Because it goes back to that parent function, okay? And I'll show you what that parent function is that I'm referencing, okay? So if I pull up Desmos, y equals x to the third. Okay, that's what we're talking about. Okay, this side on the left is pointing down. This side over here is pointing up. This would be positive. Okay, look what happens when I make it negative. Okay, so the leading coefficient is positive here. The leading coefficient is negative here. Okay, all right. So let's go back. All right, transformation functions. Okay, now this is a discovery, which means you don't get anything wrong. Okay, you actually just keep typing it in until you get your dotted. Okay, so you want your dotted and this solid, you want it to match. Okay, so now it says transform the solid black function to match the dotted function. Okay, and you've got some stuff here that you're going to fill in, and this is the discovery part. Okay, so if it's positive, okay, so let's say if I change it to negative, what happens? Okay, well that flips it over. I don't want that because I want this dotted line and this black to actually match up. So positive. Okay. Now I'm going to just put values in here. So positive and negative numbers. Well, at the moment it's 0. So what happens if I put 1? You got to press enter to activate it. Oh, okay. So it moved to the left. Okay. So if I put 2, I bet you it's going to keep moving. Yes. Okay, so that's moving farther away than I want. So let's go back to 0. Okay. I want it to move over 3 because that puts it in line. So I want to go over 3. So instead of putting positive 3, I'm going to put negative 3. Oh, there we go. Okay. Now I've got it at 0. Okay. Well, logically, if I go up, I'm probably going to use positive numbers. And if I go down, that would be negative numbers. So let's test my theory. So if I put negative 1, what happens? It moved down. Okay, so I'm going to go back to 0. Okay, and I want to go up here. So 1, 2, 3, 4, 5. Press enter. Bam. It says that is correct. You may now press submit. Okay, so that's what you're going to do for this one. Okay, now I'm not going to go over the next one. Okay, because now, okay, you're going to do what it says to do. Okay, you're going to look at this equation, okay, and you're going to manipulate the dots. Okay, so let me go back to the other one. Okay, all right, so problem types. Let's switch over to an absolute value. Okay, all right, so I've got this one. It's the same thing. If I just press negative, that's no good. Okay, you can see how the function's changing. Okay, so I'm going to just put in +1, or 1, sorry. Okay, that's actually a good thing. Okay, and then I'm going to go up 3. Let's see what happens. There we go. Okay, so that's how you're going to do this one. Okay, it's going to run you through a bunch of different types. Okay, all right, now this one, yeah, like I said, you've got this. Now, here's your hint on this one. Okay, and you just look at the dots. It moves around. There's takes you back to the original. If you're looking at it and you're like, I'm not sure what I need to do to make this picture appear, okay? Because what they've given you, okay, they've given you the parent function, okay? And they want you to manipulate the parent function to this. I will give you a hint. Desmos. And that's all I'm going to say. All right. Good luck. If you have questions, let me know.